Hi, I'm Professor Goins. In this video, I'm going to look at the equation of a circle. Before we get to circles, let's take a look at this following from a previous video. So recall, if I have 2 points in the plane, so this red point, this red dot, and this red dot, which would be A1, B1, this would be A2, B2, the distance between those we find using the Pythagorean theorem. So remember that I can turn this into a right triangle. So the square of this would be the square of this length, which is A2 minus A1, plus the square of this length, which would be B2 minus B1, and then I would take the square root of that to get the distance formula. So this right here gives you the distance between any pair of points in the plane. Now let's look at the concept of a circle. The circle means if I have this point here, which is over A, B, and we call that the center, the circle with a radius r centered on AB consists of every single point that has distance r from it. So if this point here has distance r from the center, that point would be on the circle. I could go in another direction and say, well, this point right here also has distance r. This point over here also has distance r. And we could go in all sorts of directions here. And what happens is when I plot all of those points, we get what amounts to a circle. So what's the equation for this? Well, x comma y is a point on the circle with center AB and radius R. IFF is an abbreviation for if and only if. So if and only if the distance between AB and XY is R, and R is the square root of the change in the x's, so x minus a squared plus y minus b squared. And typically the way we write this is we square both sides of that to write the following for the equation of the circle with center AB and radius r. So r squared is x minus a squared plus y minus b squared. Okay, so there's the equation of the circle. And let's do a few examples of finding centers, radiuses, and graphing these. So, for example, find the center, radius, and graph. Okay. Part A. Let's do x minus 1 squared plus y plus 2 squared is equal to 4. And part B, x squared plus 4x plus y squared minus 6y is equal to, I should have prepared this ahead of time to make this work out nicely, but let's see. If I want that to work out nicely, that would be make that a 3. Let's see if I did that right. Okay, so solution. So notice this equation right here is in the exact form that I have in this box. So this is what we would call the standard form of the equation. This one here is not in that form. This would be the general form. So we'll start with this one. Again, it's part A, so obviously we'll start with it, but it's part A, and it's in the correct form, so there's not really much work to do. We can simply write down the information. The center So notice this is x minus a and this is y minus b. So the center is a comma b, which we would have to have a negative in there. So technically what I would have to do is make this y plus 2, make it y minus minus 2. And so your center would be negative 1, or I'm sorry, positive 1, positive 1, negative 2. So you could think of it as opposite sign, opposite sign. So that'd be 1, 2, and the radius. Remember that the equation has the square of the radius in it, so I have to take the square root of this. Square root of that would be plus and minus 2, but radius is a distance, right? As we emphasized over here, the radius is that distance, so it would have to be the positive or the principal square root. Okay, so then to get a sketch of this, all right, so my center is over 1 and then down 2. So that means my center is right here. Radius of 2, so let's pick some specific points that are on there. So this would have distance 2 away. This would have distance, so let's see, 1, 2, 2, 2. So roughly that picture right there. And again, every single point on the circle, let's say this one right here, is distance 2. Okay, so let's take a look at part B. Okay, and part B, again, this is the general form, and we have to convert it to standard form. So the technique for that, going from a standard form to a general form to a standard form, is the same thing when we did quadratic functions. Means we have to complete the square. In this particular example, we have to complete the square on x and complete the square on y, so we have to do it twice. Okay, so here we go. So we've got x squared plus 4x. So then I'll add half the coefficient of x over 2. More precisely, the coefficient of x over 2, not half the coefficient of x over 2. So 4 over 2 squared minus 4 over 2 squared, and then plus y squared minus 6y plus negative 6 over 2 squared minus that same value, and it just barely ran out of space, equal to 3. So again, the only things I introduced here as a reminder were this term and those two terms and those two terms. And it's always, you take the coefficient of x, divide it by 2, square it, add it and subtract it. So I did that here and I did it here. All right. So then what we do is we're going to combine those three terms and factor it. Those three terms and factor. And then those three numbers we'll put all on the same side. Okay, so remember the shortcut for factoring a quadratic when we're completing the square is this is going to be x. It's going to be a perfect square where the number that goes in the parentheses here is the number that was in the parentheses up here, so that would be x plus 2. And then same thing with the y terms. I've got a negative 6 over 2, so that would give me a negative 3. And then on the other side, let's see, 4 over 2 would be 2. 2 squared is 4. So I've got the 3 over there already. I'll add 4. Add 4. And then this would be negative 6 over 2, which would be 3. 3 squared is 9. Add 9 to the other side, so I've got plus 9. And let's see, so 3, 4, it'd be 7. So that does give me 16. And again, it works no matter what number I have over there, as long as it's positive. But just for the sake of doing examples on the board, it's nice when it's a perfect square. So, all right, so therefore, we have our center so remember, it's going to be negative 2, comma 3. And radius, remember this is r squared, so it's the square root of that, and the principal square root because it's a distance, so that'd be a 4. Okay, so let's see what the graph of this would look like. Okay, so let's see, we're going to go back to up 3, so focus on this part here, so let's see. All right, so center is negative 2, 3, so back to up 3, so 1, 2, 3. So your center is approximately right there. And your radius is 4, so let's just kind of pick some points. So let's see, radius is 4, so 1 point on the graph would be, so here's 1, 2, 3, 4. 1, 2, that's 3, so here, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it'll be approximately that's a horrible circle, but you get the idea. Center over 2 up 3, and then every point around it that has distance 4 constructs the circle.